Hey everyone, so welcome back to the channel. It's been a while I make a full video, so thought of making again. So let's continue. I hope I will continue with the full videos. Yeah, if you are in data engineering, analytics, or even IT, I guarantee you have been hearing the word Snowflake everywhere. In job descriptions, in interviews, in company tech stacks, it's unavoidable right now. So the thing is, most people use the word without actually understanding what Snowflake is. Not really. They know it's a data warehouse in the cloud, and that is about it. That's all. So today we are going to fix that completely. So in the next coming 15 minutes or maybe 20 minutes or so, I'm going to take you from zero to properly understanding Snowflake. We will cover. Obviously, it's part one. So I will be making part two, part three, so on. Okay. So in this part, we will cover why traditional databases fail to handle modern data and what problems Snowflake was built to solve, exactly what Snowflake is and how it's different from everything that came before it. The unique three-layer architecture that makes Snowflake so incredibly fast and scalable. How it compares to Amazon Redshift and Google BigQuery. Real companies using Snowflake and what they are doing with it. And why this skill is genuinely one of the most valuable things you can add to your CV right now. So, like I said, this is part one of 10-part Snowflake series. By the end of all 10 parts, you will have everything you need to work with Snowflake professionally. And be ready for the Snow Pro Core certification. So, make sure you subscribe and hit the bell so you don't miss a single part. Alright, let's go into it. So the problem before Snowflake. To understand why Snowflake exists, we need to understand the problem it was built to solve. And the problem starts with traditional databases. Think about tools like MySQL, PostgreSQL, Oracle. These are OLTP databases, online transactional processing. They are incredibly good at what they do, inserting rows, updating records, fast reads of individual entries. They power your e-commerce website, your banking apps, your CRM, but they were never designed for analytics at scale. As data started growing, and I mean really growing, right, these days, every single second, so much data is creating. Companies realized they needed something different. They needed to run complex analytical queries across billions of rows. And that is when traditional data warehouses like Teradata and later Amazon Redshift came in. But even these had massive problems. Three specific ones. Problem one, storage and compute were coupled together. In older data warehouses, your storage and your compute power were tied together. You bought a cluster, and that cluster had a fixed amount of storage and a fixed amount of processing power. If you needed more compute to run big queries faster, you had to scale the entire cluster, which meant scaling storage you didn't need. You are paying for capacity you were not using. Hugely expensive, hugely inefficient. Problem 2. Semi-structured data was a nightmare. Modern data doesn't just come in neat rows and columns anymore. You have JSON files from APIs, Paraquet files from Spark jobs, Avro from Kafka streams. Traditional warehouses choked on this. You needed separate tools, separate pipelines, separate teams just to handle semi-structured data before you could even load into your warehouse. Extremely painful and slow. Problem 3. No cloud elasticity. Traditional warehouses were built for on-premises infrastructure. You had to plan capacity months in advance. You would buy servers for peak load, and those servers sat idle 70% of the time, quietly burning your company's budget. There was no scale up for Monday morning reports and scale back down by evening. You are stuck. So in 2012, three ex Oracle engineers, Benoit, Degavel, Terry and Marcin, said enough. They designed a brand new data platform from the ground up, built specifically for the cloud to solve all three of these problems simultaneously. That platform was Snowflake. What is Snowflake? Snowflake is a fully managed cloud native data cloud platform, and I want to break that phrase down word by word because every single part of it matters. So what exactly Snowflake, right? So like I said, let's break it down. Fully managed. You don't touch any infrastructure, no servers to provision, no clusters to configure, no database software to install or patch. Snowflake handles all of that. You just log in, write SQL, and query your data. Your team focuses on insights, not infrastructure. Next, cloud native. Snowflake wasn't built for data center and then moved to the cloud. It was designed for the cloud from day one, specifically to run on AWS, Azure, and Google Cloud. This means it uses cloud native features like elastic scaling, pay per use pricing, and global availability natively. Lastly, data cloud platform. This is big one. Snowflake is not just a warehouse anymore. It's full platform covering data warehousing, data lakes, data engineering pipelines, data science workloads, data sharing between organizations, and increasingly even application development. Everything is one place. Snowflake's impressive scale. So let me give you a sense of how big Snowflake has become. Like I said earlier, founded in 2012 by three people, and so by three ex Oracle engineers. In fact, over 9,400 enterprise customers as of early 2025. 30% of Fortune 500 companies use Snowflake. $3.3 billion in annual revenue, one of the fastest enterprise software companies in history. Runs on AWS, Azure, and Google Cloud. You see, choose which one fits your company. So Warren Buffett's Berkshire Hathaway invested in Snowflake. So that is how seriously the business world takes it. The key thing to remember is this: Snowflake is not your grandfather's data warehouse. It is completely new category of software, and it is the platform that is powering the data strategies of the world's best companies right now. So the three-layer architecture. Now let's get into most important technical concept in all of Snowflake, its architecture. This is what makes Snowflake genuinely different, and this is the concept that comes up in literally every Snowflake interview. Snowflake has a three-layer architecture, three completely separate layers that work together but can scale independently. So let's go through each one. Cloud services. This is the top layer. and it is the most invisible one. The cloud services layer is essentially the brain of Snowflake. It handles everything that happens before and after your query runs. So, firstly, authentication, verifying who you are when you log in. Access control, checking what you are allowed to see and do. Query parsing and optimization, taking your SQL and figuring out the most efficient way to run it. Metadata management, keeping track of all your tables, schemas, and micro partitions. Next, infrastructure management, handling all the data cloud plumbing underneath. The cloud services layers runs continuously. It is shared across all users and it is what makes Snowflake feel like magic when you run a query because all the heavy thinking has already been done before the compute even starts. Layer 2, query processing. This is where your SQL actually gets executed. In Snowflake, the compute layer consists of something called virtual warehouses. A virtual warehouse is essentially a cluster of compute resources, CPU, and memory that executes your queries. Here is what makes this layer special, and this is the key insight that separates Snowflake from everything before it. So, there are four key things that we are going to discuss. Firstly, you can have multiple virtual warehouses all reading from the same data at the same time. Your business intelligence team's warehouse doesn't compete with your data science team's warehouse. Virtual warehouses auto suspend when not in use. No queries, no charges. They auto resume in seconds when you need them again. You can scale a virtual warehouse up or down from extra small to 6x large with a single click even while a query is running. Lastly, you can create as many warehouses as you need. A warehouse for ETL pipelines, a separate one for dashboards, another one for ad hoc analysis. This complete separation of compute from storage is the single most important architecture decision Snowflake made. It is why they could offer a pricing model that no traditional warehouse could match. Layer 3, database storage, the foundation. The bottom layer is storage, and this is where your actual data lives. Snowflake stores all your data in the cloud, providers object storage, that is Amazon S3 buckets if you are on AWS, Azure Blob Storage on Azure, and Google Cloud Storage on GCP, Google Cloud Platform. But Snowflake doesn't just dump your data in there as raw files. It transforms your data into its own optimized columnar format and organizes it into what it calls micro partitions. A micro partition is a small chunk of data, typically 50 to 500 megabytes of uncompressed data stored in columnar format. Snowflake tracks rich metadata about every micro partition, what range of value it contains, what the min and max values are, how many distinct values these are. This metadata is what allows Snowflake to skip entire micro partitions when answering a query. It only reads the data it actually needs. The bottom line, your data sits in cheap, scalable object storage, costing pennies per GB, completely independent of compute. You pay for storage even when zero queries are running. And multiple virtual warehouses can all read from the same storage simultaneously without competing for resources. So, traditional database versus data warehouses versus Snowflakes. So, let's compare all of these three. So, I get this question a lot. If I already know MySQL or PostgreSQL, why do I need Snowflake? And if I am already using Redshift, why would I switch? So, let me clear this up with a direct comparison. Traditional database versus MySQL, PostgreSQL, Oracle. So these are OLTP, online transactional processing systems. They are brilliant at handling thousands of small read and write operations per second. Your e-commerce order system, your user authentication database, these live here. But the moment you try to run a calculate revenue by product category for last 3 years across 10 billion rows query, these systems will either take hours or just fall over. So data warehouses, Redshift, Teradata, SQL Server, DW. These are OLAP, online analytic processing systems, designed specifically for complex analytical queries over huge datasets, better than traditional DBs for analytics. But they come with the three problems we talked about earlier: coupled compute and storage, poor handling of semi-structured data, and rigid scaling. You commit to a cluster size and you are stuck with it. So now let's discuss about Snowflake, a new category entirely. Snowflake does everything a data warehouse does, but it also handles semi-structured data natively with its variant data type, scales compute independently from storage, supports concurrent workloads without resource contention, and requires zero infrastructure management. It is not just a better data warehouse, it is a platform that replaces multiple tools at once. So the analogy I like, a traditional database is a bicycle. A traditional data warehouse is a car, and Snowflake is self-driving electronic vehicle with autopilot. Same destination, completely different experience. Snowflake, Redshift, BigQuery. So let's have a look. So the competition, because when you are recommending a data platform at work or studying for an interview, people will ask why Snowflake and not Redshift or BigQuery. So here is the honest answer. Amazon Redshift. Redshift is Amazon's data warehouse. If your entire company runs on AWS and you have no intention of going multi-cloud, Redshift is a solid choice. It integrates deeply with the AWS ecosystem, S3, Glue, QuickSight. But this is a big but. It is AWS only. The moment your company has data in Azure or GCP, Redshift become a silo. It also requires more tuning, more cluster management, and has historically had more operational overhead than Snowflake. Google BigQuery. BigQuery is Google's fully serverless data warehouse, no clusters to manage at all. Very similar to Snowflake's fully managed approach. It is excellent for large scale analytics and integrates beautifully with Google Analytics, Looker, and other GCP tools. But again, it is GCP only, and it is pricing model on demand for per TB of data scanned can produce nasty billing surprises when someone runs an unoptimized query against a huge table. So, why Snowflake wins in many situations? Multi-cloud freedom. Snowflake runs on AWS, Azure, and even GCP. Your data team is not locked into one vendor. You can even replicate data across clouds natively. Consistent experience. The SQL syntax, the UI features all identical regardless of which could you are on. Teams can move between cloud providers without relearning the platform. Supervisor data sharing. Snowflake's data sharing feature lets you securely share live data with other organizations. Even organizations that don't use Snowflake with zero data movement and zero data copying. Semi-structured data. Snowflake's native variant type lets you query JSON, Paraquet, and Avro directly without pre-processing. This is genuinely better than Redshift and comparable with BigQuery. Concurrency. Multiple teams can run large queries simultaneously without competing for resources. Each team gets its own virtual warehouse. The honest answer is all three are good tools, and the best choice depends on your cloud provider and use case. But Snowflake's multi cloud neutrality and ease of use give it a unique advantage, which is why so many companies choose it as their primary platform. So, who uses Snowflake? I think, yeah, that's enough theory. So, let me show you some real companies and what they are actually doing with Snowflake, because this is what really bring it to life. Adobe. Adobe has 12 plus products: Create Cloud, Document Cloud, Experience Cloud, generating hundreds of terabytes of customer data daily. They built their entire unified analytics platform on Snowflake, consolidating what used to be six separate analytics systems into a single data cloud. Real-time customer behavioral data from Photoshop, Premiere Pro, Acrobat, all running on Snowflake. Capital One. Capital One is one of the most aggressive cloud adopters in banking. They migrated their entire data warehouse to Snowflake, replacing five legacy systems in the process. They now run credit risk models, fraud detection, and customer analytics all on Snowflake. So, that is a regulated financial institution trusting Snowflake with their most sensitive data. Airbnb. Airbnb processes millions of bookings, events, host interactions, and payment transactions every single day. They use Snowflake as their primary data warehouse and pair it with dbt, which we will cover in part 8 of this series, to build and maintain their data pipeline, reduce time to insight from days to hours. JetBlue. JetBlue uses Snowflake for flight operations analytics and passenger behavior analysis. Before Snowflake, certain query jobs took 6 plus hours to run overnight. After migrating to Snowflake, those same queries run in seconds. That is the kind of transformation that changes how a business operates. DoorDash. DoorDash handles over 50 million food delivery orders per month. They use Snowflake's data sharing feature to securely share restaurant performance data with their restaurant partners, giving restaurant real-time visibility into their metrics without DoorDash copying any data. Siemens. Siemens uses Snowflake to process LOT sensor data over 3 lakh industrial devices across manufacturing plants worldwide. We are talking real-time operational data from machines analyzed at scale. Snowflake wasn't just built for the internet. It handles industrial data at massive scale too. Finance, creative software, travel, logistics, industrial manufacturing. Snowflake is genuinely cross-industry. That breadth of adoption is what makes it such a valuable skill. There are very few industries where this knowledge won't be applicable. Snowflake by the numbers. So let me hit you with some numbers that show just how significant Snowflake has become. 9,400 enterprise customers, Quarter 1 financial year 2025, and that numbers grows every quarter. So 30% of Fortune 500 big companies are Snowflake customers. That is the biggest names in every industry. $3.3 billion in annual revenue for financial 2024, one of the fastest growing enterprise software companies ever, going from 0 to $1 billion in revenue under 8 years. 128x faster queries. Faster query performance compared to legacy on-premises data warehouse in benchmark tests. 3 clouds. Fully supported AWS, Azure, Google Cloud Platform. 3 multi-cloud neutrally. 0 infrastructure for you to manage. No servers, no clusters, no database administration, fully managed. So these numbers are not just impressive. They tell you something important about skill demand. Companies don't invest this heavily in a platform and then hire people who don't know it. Snowflake knowledge is now a hiring requirement, not a nice to have skill. So why you should learn Snowflake? So let me be direct with you about this career side of this, because this is what you are really here for. So the demand is really, and it's growing. Snowflake skills appears it's over 40% of all data engineering job posting right now. That number was under 10% 5 years ago. Companies are moving fast. They are adopting Snowflake and they desperately need people who already know how to use it. The salary premium is significant. Based on market data across LinkedIn, Glassdoor, and levels. So for your information, professionals with Snowflake on their CV earn 20 to 30% more than comparable roles without it. In India, a data engineer with Snowflake experience commands 15 to 25 LPA at mid-level compared to 10 to 15 LPA without. So globally, senior Snowflake roles regularly exceeded $150,000. So the Snow Pro core certification, Snowflake offers an official certification called Snow Pro. It is the entry level certification and it is become one of the fastest growing cloud certification in the industry. It covers exactly what we are teaching in this series: architecture, data loading, virtual warehouses, performance, security, key practices. We will dedicate part 10 of this series specifically to interview prep and how to pass Snow Pro core. So roles that use Snowflake. Snowflake is not just for data engineers. Here are the roles where Snowflake knowledge is directly applicable. Data engineer, primary user, building pipelines, loads data, manages transformations. Analytics engineer, uses dbt plus Snowflake to build the business logic layer. Data analyst writes SQL in Snowflake to answer business questions. Business intelligence developer, BI developer, connects Tableau or Power BI or Looker to Snowflake for dashboards. Cloud architect designs the overall data platform strategy. Next, ML engineer uses Snowpark to run Python and ML models inside Snowflake. Data platform lead or head of data owns the entire Snowflake environment. So if you are in any of these roles or aspiring to any of them, learning Snowflake is one of the highest return of investments of your time right now. So all right, so let's wrap up part 1. I thought I would complete in 15 to 20 minutes, but it is taking more than that. Yeah, so Snowflake was born because traditional databases and early data warehouses could not scale compute and storage independently, could not handle semi-structured data, and were not built for the cloud. Snowflake is fully managed cloud-native data cloud platform, and not just a data warehouse, but a complete data platform. It is unique. 3-layer architecture separates cloud services, query processing via virtual warehouses, and database storage, allowing each to scale completely independent. It runs on AWS, Azure, and Google Cloud. True multi-cloud freedom with zero vendor lock-in. Over 9,400 enterprise customers, $3.3 billion in revenue, and uses companies in every major industry. Snowflake is the dominant cloud data platform right now. So, yeah. So in part 2, we are going, like, I will walk you through setting up completely free Snowflake trial account. So no credit required. So see you in the next video. Thank you.